All right. Hello, everyone, and welcome to the MoldX 3D webinar series. My name is April Brown. I'm the applications engineer from the MoldX 3D North American office in Farmington Hills, Michigan. And today we're going to be talking about efficient simulation strategies for high cavitation systems. All right, so let's get started with today's outline. So there's going to be two main types of modeling with multi-cavities. There's going to be symmetry and full model analysis. A full model incorporates all the cavities, the entire runner system, whether it's a cold runner or a hot runner. And the benefits of symmetry is to save you time, energy, and resources. So we'll discuss what exactly that is, when we use it, why we use it, and how to use it. We'll discuss the line-define runner approach and why it's important. And then what situations would you want to use the solid geometry runner approach? And lastly, the cost-effective, like progressive analysis, which is how we can efficiently run a simulation. So what is symmetry? It is important to note that this feature considers that you have symmetrical parts and a symmetrical runner. So let's say you have a 32 cavity mold. You have two approaches here. You can either model all 32 cavities or you can apply symmetry. And symmetry is running a section of that 32 cavity tool. And this function will still represent the entire model with the same number of cavities, but now you have the option of just 1/2 or 1/4 symmetry options. Now that level will be dependent on your runner layout, and there's going to be two approaches to that runner layout. Those two approaches I'm going to discuss in the following slides. So that's going to be accurate modeling and then branched modeling.